All right, so welcome back. And for our latest project, we're going to be taking a look at this very nice old MCS series integrated amplifier. This is a viewer submitted unit. This comes from Jim. He lives in Oregon. And the story of this amplifier dates all the way back to the early 80s when him and his late wife bought the complete stereo system that this amplifier goes with. I believe he said it was 1984, and I believe the price for the 5 pieces, which would have included the tape deck, the amplifier, the speakers, the tuner, and possibly a turntable if I remember right, I believe it was around $900, which was a fortune to spend on something like this back in those days. So he had seen one of my videos and got in touch with me about taking a look at this one for him. And apparently what is going on is we have some static in the volume control, which is not very surprising for something this old. And basically just some overall maintenance that he wants done to this just to get it back up and going correctly so he can start using the unit with the rest of the stereo. So in this video, we'll find out what's going on with this. Aside from static in the controls, have a look at the solder work, how all that has held up over the years. And if you know anything about MCS series or sold at JCPenney audio equipment, not all of it was made by Technics, but I think if you know anything about audio equipment in general, it's very easy to see this piece was. Very Technics looking in the front, especially the power button, and the speaker switches kind of give it away with the whole main and remote thing. And of course the speaker connections in the back will certainly give it away. So as always, we'll come in, we'll have a look at the controls and features of the unit, as well as the connections they provided in the back. And as for our intro music this time, we're gonna go back to 1982, checking out Van Halen's Diver Down album. And this was actually something that Jim had mentioned to me. I believe he said his wife had given him a cassette copy of this album back in the day, which got me thinking about the record. And one of my favorite songs from this, which is called Secrets. So let's check out a little bit of this and then we'll get started on the MCS.
Crazy if she can go. I'm looking good. Oh, yes.
All right, let's go ahead and pick back up. We'll take a quick tour of the controls and features on the unit. Starting on the far left here, we have the latching power switch. Right below that, a 1/4-inch headphones jack. Then they have the speaker systems labeled main and remote. Again, another dead giveaway of how Technics would do it in systems prior to this one being made. Above that, they have some LED wattage meters here for you. And they have this one at 100 watts per channel. Probably a good indication. We'll find some discrete outputs inside here. Bass and treble controls. Above that, you have the meter range. You have the subsonic and high filter switches below that, mono and stereo. Then you get your source selections. You've got a tape monitor here as well as an auxiliary, tuner, and phono. Above that, a sliding balance control, a loudness switch, and then a rotary volume control. Let's flip it around. We'll take a look at the back. Should have another good indicator of Technics as the maker. Start on the left here. You have the connections for all your sources, phono, tuner, auxiliary, record out, playback for the tape monitor, and then of course the very famous Technics locking speaker wire connections here for both main and remote. 3 outlets, 2 unswitched, 1 switched. That's pretty much it. Now, one thing I noticed about this is if you take a look at the back here, we have the wide screws, which would typically be found on the side. We have those on the back, and I'm not sure if maybe it had been worked on at one point and these were put in the wrong spot, or maybe this is the way that it came. Maybe this was something that they did for the MCS version versus Technics themselves. I'm not sure. I think I'm definitely going to be tempted to want to put those back in the side when it's time to put this back together. So I guess the first thing we'll do, let's go ahead and get it hooked up, and we'll confirm we have the static and the volume control, but at least make sure that both channels are working, and then we will go from there. All right, let's go ahead and come back in. We'll take a fast look at the inside here. All looks very familiar to me. And the transformer off to the left here with a fuse next to the power switch. Outputs appear to be Sanken, from what I can tell. Have kind of that Techniques heatsink. They use some kind of a copper tube. They may have even put something in the tube, Freon maybe or something, and then ran it over to the heatsink. And basically the outputs just kind of clamp to the back of that aluminum piece here, which is clamped to that copper tube. Transfers the heat over there. Did notice a couple of things here. Capacitor wise, use their own capacitors in this. There's some tin mic caps that definitely have corrosion on the leads for sure. The exact same two in both channels, right and left of the supporting circuitry for the amp here. There's a couple others, same value, 10 mics, I believe, over on this board maybe. So we'll be definitely looking into that, but this is what we got for sound. It's horrible. That's with the speakers on. I mean, it's really to the point where I definitely don't want to damage the tweeters in my bench speakers. So I think the first thing we'll do, and I'm not sure that that's going to fix the whole thing. Let's clean the volume control up real quick. I'll shoot some control cleaner in that, and we'll see if that'll bring it back to where we can get the volume under control and hear what we have. But I thought I only seen activity in the left channel. I didn't see any activity here, and I barely heard anything in the right channel, so I'm not sure what's going on with that yet. But let's clean the volume control up real quick first. Seems like that'll be fairly straightforward to do. Probably don't want to try to, I might be able to get it from the side there, on the other side. Yeah, let me go ahead and see, let me shoot some cleaner in that. I'll bring you back and we'll see if we got it cleaned up to the point where we can hear actually what's going on. So give me a moment for that. All right, as we come back in here, some control cleaner did get this cleaned up, but I had to do it a couple of times and it was still a little touchy after that. So we got both channels working. And the amp is definitely not short on power. It'll jam if you want it to do that. Couple of things though. The balance control needs some work for sure. All the way to the right, both sides still working. So this one, we're not going to be spraying any control cleaner from the front. We're going to have to take that control out. I think I want to take this one out and take it apart as well. Some other notable issues, the tape monitor. Just pushing it a couple of times will cause the one channel to cut out, so that's going to need a little work. That we can probably do with just control cleaner. Getting some control cleaner in it should probably fix that because it's not that bad. This definitely is going to have to come apart and be cleaned down to component level. This I think I'm going to take apart, even though it's working, and clean it that way as well. So I guess the first step here, let's go ahead and start taking the front apart so we can get down to where this is at. This should come out pretty easily. This one is a different story though. So I'm going to go ahead and get the front piece of it off. I'll bring you back once I have that off, and we'll unsolder this and start working on it. We'll take it apart and have a look at it. All right, as we pick back up here, I went ahead and got the volume control out first. Went ahead and pulled the balance control at the same time. And this one is pretty easy to clean. The only problem is if we take a look here, you can see how the front section of the control is press fitted into this. So there's not a real good way to get underneath the contacts coming into touching the resistor board here. So what I've been doing is just kind of working it back and forth with a piece of paper. This is a very thin piece of paper, and so I've just kind of got it caught up underneath right there and just working the control back and forth, and it gets a lot of that buildup off. So that's kind of what I've been doing. That's kind of my method there. Everything else I can clean up pretty good with Q-tips, but this, there's no way we're going to try to take that apart. We'd break the control. I'd break the control, I should say. So there's no way that's happening. Definitely not doing that. Keep in mind, it was working when I took it apart. It's just a preventive maintenance. One of the things I wanted to make sure of is that one of these plastic tabs right here, I wanted to make sure one of these tabs wasn't broken. And it's not. This is solid. It's in good shape. It was just very, very dirty. Lots of buildup in it. I mean, you can see the black coming off of these Q-tips here. So I think what I'm going to do is I'm going to spray this out one last time and then probably blow it out with a compressor to get all the excess cleaner out of it. And I think we should be okay. So I'm going to go ahead and get this one back together, and then we'll start on the balance control. All right, as we come back in, I went ahead and got the balance control apart. And the reason that you never want to shoot control cleaner in from the front of one of these is because you don't want to disrupt the damping fluid. And if you squirt control cleaner in that, you're going to ruin the damping fluid. It's going to work, but it's going to slide back and forth, very sloppy. And so that's why you want to take one of these apart. What we want to clean up here, obviously, is just the resistor. And we'll just put a little control cleaner on the Q-tip to do that with. I'm going to squirt a little on my Q-tip here. And then we'll just run it along this resistor. And this, you can see what's coming off right there. Very nasty stuff. Go to the other side. Clean that up. And then we'll put a clean layer on top of that. But first, we've got a little bit right down there in one of the contact points that I want to get off. But I don't want to bend it trying to take it off. So I'm just going to try to swipe it here. And that seems to be fine. Because if you get a Q-tip caught underneath this and pull up on it, you'll bend it, which you can straighten back out, but that should be just perfect there. So we'll do one more clean Q-tip with some control cleaner here. And that should be good. Don't want to leave excessive control cleaner in that. And then I'm going to take the Q-tip and just brush these contacts with it. Like so. And that will do it. Then we'll put her back together here. I just got to remember which way it goes. And I left myself a little mark right here next to the M. Probably can't see it on camera, but and then we'll just bend these over a little bit. Don't need to go nuts. There we go. And we preserve the damping fluid, and the control will be, should be, spot on. So I think before we go any further, I'm going to clean all of the push button controls, but I want to stick this back in, and we're going to fire it up one last time, make sure everything's working the way we want it to, and then we'll spray out the push button controls. And then we can move on to something else. So give me a moment for that, and we'll pick back up. All right, let's go ahead and pick back up. I went ahead and got our balance control put back in, volume control put back in. They both seem to be working noise-free. Take a look at the balance control here on the meters. No bleed over to the right channel there. And no bleed over to the left channel. Also no static, and we were able to preserve the damping fluid in that. Bass and treble seem silent to me. I thought I may have heard some static there, but I don't hear anything static-wise in that now. So I'm probably not going to mess with that since it does have damping fluid in it. But these controls here, the push button controls, I'm going to have to go ahead and see. I thought I maybe could get some fluid in from the front, but I don't know about that now, so I might have to go ahead and just drill a tiny hole in the back of the control if I can, and get some fluid in that way. So let me go ahead, I'm going to work on that, then I'll bring you back and show you what I found. I'm not going to spend a lot of time on these push button controls. I believe I have another video where I show that procedure where I do that. I'm more interested in moving on to the capacitors, the ones that are corroded, and see if we can get those out of there and get those switched. And then we'll do an idle current check on this and see if we can get it wrapped up today. So give me a moment for that, but otherwise, this old amp is coming back. Sounds pretty good. All right, let's go ahead and come back in. I'll show you what I found with the switches. Basically, I wasn't able to get control cleaner in through the front. Probably could have, but I would probably used a half a can trying to do it and flooded the whole freaking board and everything. So I decided to do a method that I've been doing for a long time, but you can only do it on certain switches. And that is just to drill myself a tiny hole in the back of the control. Basically what I use is a very tiny drill bit and just kind of bore myself a small hole there. But you can't do it with all switches. In this particular case, I don't know how well the camera will pick this up, but the control we're focused on right here, I'm actually moving. I'm latching and unlatching it. And the inside portion of this is the outside portion, obviously. The inside portion of this only comes to about right there where that DC is written. It doesn't go any further than that. If it reached all the way to the back, I wouldn't have been able to do this. But because it don't, there's some open space right there. So I just bored a tiny hole in this. And then I was able to get a straw into the hole and put some control cleaner in it. It's a method that works very well. But again, you have to be able, and the camera's not picking this up, but if you were standing here looking at it, you can see the inside portion moving back and forth, and you can tell that it stops about right here. So that gives you some open space back here. If it went all the way, the entire length of the outside portion, and you tried to drill a hole, or you did drill a hole, Then when you got ready to push the control and lock it into place, it wouldn't lock because that hole, as you're drilling it out, of course, is going to leave some ragged material on the other side. And so that would not, the inside portion wouldn't move smoothly against that hole. So that's how I'm able to get away with that on these type of controls. If you have some that are absolutely completely filled front to back where you don't have any kind of room to do that, really the only method to correctly do it, if you don't want to just flood the whole entire amplifier with control cleaner, is to take the controls out of the board, take them apart one by one and clean them, which is very time consuming to do, but sometimes you don't have any choice. So we're going to move on, looking at the capacitors here. And again, not so sure how the camera will interpret this. And I've checked every one of these here. They're all perfectly fine, including the one that needs to be changed. You maybe can see there is a little bit of corrosion there on those leads of that capacitor. Let me see if I can get you in a little closer here. It's really tough to see it. But yeah, there's corrosion on those leads, but yet that capacitor does check fine, but we're not going to leave it that way. So there seems to be a pattern here down on the main circuit board. It seems to be 10 mic capacitors, but I believe this is 33 microfarad capacitor. And so, yeah, we're going to go ahead and change this out for sure and put a different one there. But otherwise, on that board, that's the only thing. All these other capacitors are perfectly fine. There's 1 mic, 50, 4.7 at 50. Those are perfectly good. We're not going to mess with those. So we're just going to focus our attention on the 33 mic, which I will get us one here. Just can't leave it in there with the corrosion on it. It would definitely turn into an issue, even though it may not be an issue at the moment. It would definitely turn into one. So let's go ahead and pull that one out. And then we can get a much better look at it. You can see what I'm talking about. Maybe. This thing will. It's on the negative lead right there. And yeah, you can see it. It's starting to be green and corroded, or at the very least corroded. So yeah, we're definitely going to swap that one out for sure. And any others that we find like that. I'm going to be using Panasonic capacitors to go back in there. I believe the one that came out is 33 at 25. We're going to use a 33 at 50. You can even see the corrosion right there on the board. Let's wipe that up. That will take care of that one. And we will wipe that off since the unit is in such good shape. But yes, all the others here, no issues at all with corrosion. So it seems to be just affecting, in this particular case, the 33 and 10 mic. So I'm going to go ahead and slide this board back in, and then we're going to move down to these two boards right here, because I believe there's a couple on each one. Let me go ahead and get this mounted back in, and then I'll pick back up with you, and we'll start on the other two boards. All right, as we go ahead and pick back up here, kind of give you a bottom look at the unit. Went ahead and tore it down a little further. Basically had to remove this bottom piece here, or excuse me, the back piece, and then there was a bottom access panel that came off. Basically wanted to get down into this area right here. We'll zoom in a little bit, and I'll show you what I did, which wasn't much because there wasn't much that needed to be done. First, we'll take a look at this. They had two wires right here glued down with the brown glue that can over time become conductive and discolors very, very dark color and becomes conductive. This hadn't made it to that stage yet, but I went ahead and scraped it all up and put a piece of heat shrink around these two wires since they actually contact the bottom of the unit, or they're close. There's a standoff right here that kind of prevents it, but I went ahead and shielded those in some heat shrink. And these run, of course, right into our main outputs right here. I did not touch up the solder. This is actually factory solder. It looks perfectly fine, so there was no need to mess with that. As we come into this area here, some of these driver transistors, I went ahead and touched up those. But to be honest with you, they weren't cold. I mean, the joints were perfectly fine. And of course, these speaker connections can always be an issue, so I wanted to touch up those. And then if we make our way over to the other side here, let's see. See if I can get the camera to agree. Of course, I did all the inputs here, touched all those up. Otherwise, as far as solder, no obvious cold solder joints. These were just maintenance things that I wanted to do for the inputs and for the speakers, and then touch up a little bit in the amplifier section. Let me go ahead and flip this over, and we'll take a look at some of the capacitors that I changed, which wasn't a ton. Let's see here. Got to be careful with this. It's kind of weighted on the one end, and it's kind of offset right there on the edge of the circuit board, so I don't want to crack anything. So starting over here, down in this area here, we have a stand-up board. They have it labeled protection, and I did find several caps here. Basically, we have 10 mic at 50, and then below that, this is a factory cap, a 10 mic at 50. Then below that, there was a second 10 mic at 50, which I changed accidentally. I wasn't going to change it. And then below those 10 mic at 50s was two 10 mic at 25, which had corrosion. And then over here, the two 33 mic capacitors with corrosion on the leads. So basically, here's our 33 mic caps. Might be able to get a shot of that. Definitely has some issues there. Here's the second one. And these are 33 at 25. I used 33 at 50. But I want to show you the 10 mic at 50 volt cap that I changed that I shouldn't have changed. It was perfectly fine. There was no corrosion coming out of it. So the 10 mic at 25 volt caps are bad, but this is the 10 mic at 50. And there's nothing wrong with that. There's no corrosion on those leads, and that cap checks perfectly fine. I took it out right down here, right below this one, thinking it was a 10 mic at 25 volt, and changed it, but didn't need to. These are the factory 10 mic at 25 volt. And of course these are pretty much done for. Don't know if the camera picks it up, but there is definitely corrosion down in the lead of that cap. And keep in mind, all of these check just fine. There's no issues with any of them as far as ESR is concerned, but definitely can't leave them that way. And then over here in this area is the next spot we want to go to. Down in here, we have basically, I believe it was a 47 mic. Let me see if I can find those. 47 mic cap at 25 volts, that's what I want to say. Oh, excuse me, 6.3 volts. There's one on each side, and they were both corroded leads. See if we can get in on that. Yeah, these were probably the worst ones out of all the caps that I changed is these. And so I use 47 mic 16 volt caps, actual Panasonics that look just like the ones that came out of there. So that's pretty much it for the capacitors in this. Every cap in this thing was checked. Every single one of them is perfectly fine with the exception of the ones that had the corrosion on the leads. So I believe the next thing I want to do, over here, all the caps on this little phono preamp board are 3.3 mic, and they're fine as well. All of this is good. Everything else is looking good. So I think the next thing I want to do, I want to go ahead and reassemble it and get it to the point to where we can tap onto this emitter resistor or these emitter resistors and check and see what the idle current is running at on this. So getting closer. Give me a moment for that, and we'll pick back up. All right, as we go ahead and pick back up, had the unit running on the bench for about 15 minutes, no volume, just kind of sitting, idling. And in that time, I was looking for a service manual for this. Didn't think I would find one, and I didn't. Did find some similar ones, but when it comes to making this adjustment, I really prefer to have the exact manual. So when I initially made the check on these, the left side here, assuming this is the left side, I have it now set at about 9. Let's get a little better connection there. I have it now set. What I did is I just decided to split the difference. When I found this one, it was about 20 something, 23, 24, and the one over here was at 21. And so what I decided to do was just split the difference and set them both at 10, or as close as we could get to 10. And went ahead and put a little control cleaner in the adjustment pots just to make sure there wasn't anything funny going on there, and let it set for a few minutes and then rechecked it. And so they've both been kind of hovering around 10, 10.9. And so I think we're going to be okay. Again, since I don't know the exact measurement for this, I'm going to, again, just split the difference between the two of them. Both of them were over 20, so I'm going to set them both at 10. If they drift back up there, which they very well could, that should still be okay. I think that anytime you're dealing with one of these amplifiers, trying to make that exact adjustment and keep it there is a little bit difficult to do, almost impossible, especially with an old amplifier, because too many things affect it. Don't know if the ambient temperature in the room can affect it, as well as the aging of the other transistors in the circuit, not just the output transistors. But I think we're actually going to be okay here. We'll do it one more time just to see if we're still in that ballpark. 9.6 on that side and 10 on this side. So I think we're going to be just fine. I'm going to go ahead and get the top of the unit on it, and we're going to do a final play test, and we're going to wrap this one up. All right, let's go ahead and pick up one last time, having a look at the MCS 3840 Integrated Amplifier. I want to thank Jim. Appreciate you sending this to me so I could get it going for you again. And hopefully when it's reunited with the rest of the system, you can perhaps even enjoy this album. You still have your cassette copy of Diver down. And I want to thank all you guys. Appreciate you checking out the videos on my channel as well as this video. And I think this is pretty much kind of one of those units where you think the problem is simple. We just need to clean the controls. We should be good to go. But all it takes is just a little deeper look into things. That anything that's this age, there's definitely going to be some other issues that's going to need to be checked into. So on our way out of this one, let's go ahead and check out a little bit of Cathedral from this album. We'll crank it up a little bit here.